Most adults in developed nations fail to achieve the recommended 8 hours of nightly sleep. Regularly sleeping less than 6 or 7 hours can weaken the immune system and increase the risk of serious illness. Just 1 week of short sleep can disrupt blood sugar regulation, resembling a pre-diabetic state. Reduced sleep is linked to cardiovascular strain, including blocked arteries and a higher risk of stroke. Sleep disruption is also associated with major mental health conditions, such as depression, anxiety, and suicidality. When sleep is cut short, appetite hormones shift, increasing hunger while decreasing the signal for satisfaction. Diet efforts can backfire due to sleep loss, with more weight gain coming from lean mass rather than fat. Across various outcomes, shorter sleep is correlated with a shorter lifespan, impacting both years and daily functioning. Sleep loss is so widespread that the World Health Organization has declared it an epidemic in industrialized nations. If these ideas matter, consider reading Why We Sleep by Matthew Walker and subscribing for practical sleep science you can use. Sleep appears evolutionarily risky as it reduces feeding, social interaction, mating, and protection from threats. Despite these hazards, every studied species sleeps, suggesting large benefits that outweigh vulnerability during rest. The question is not about a single purpose, but many functions that support brain and body health. In the brain, sleep supports learning, memory formation, and decision-making by restoring effective neural processing. Sleep also recalibrates emotional circuits, improving next-day composure for social and psychological challenges. Dreaming provides benefits, including soothing neurochemistry that reduces the painful memory charge while preserving information. In the body, sleep replenishes immune defenses, tunes insulin and glucose balance, and supports a healthy appetite. Adequate sleep helps maintain cardiovascular fitness and blood pressure, integrating with diet and exercise as a health trio. 1 night of poor sleep can impair mind and body more than comparable shortfalls in food or exercise. Because sleep affects so many systems, improving it can reset daily performance across cognition, mood, and physical function. 2 forces shape sleep timing: an internal clock that follows a daily rhythm and a pressure that builds during wakefulness. The internal clock, located deep in the brain, produces a near-daily circadian signal. This rhythm influences alertness, eating patterns, mood, urine production, body temperature, metabolic rate, and hormone release. In darkness, the human clock runs slightly longer than 24 hours, gradually shifting the timing. Daylight corrects the internal clock each day, keeping behavior aligned with the Earth's rotation. Light is the main reset cue, but regular food, exercise, temperature changes, and social timing can also help. The brain refers to any reset cue as a Zeitgeber, meaning a time giver that synchronizes internal rhythms. The clock structure is the suprachiasmatic nucleus, which samples light signals from the eyes through optic nerves. Melatonin conveys the darkness message throughout the body, helping set the start and end timing of sleep. Understanding circadian timing clarifies why consistent light exposure and schedules support stable sleep patterns. Alongside the clock, adenosine accumulates in the brain, creating a rising sleep pressure throughout the day. High levels of adenosine dampen wake-promoting networks and boost sleep-inducing ones, making it harder to resist sleepiness. After sufficient sleep, the brain clears much of the adenosine load, reducing sleep pressure by morning. Caffeine blocks adenosine receptors, masking sleepiness without removing adenosine, which continues to build. Caffeine levels peak about 30 minutes after intake and linger for 5 to 7 hours due to its half-life. Late caffeine can degrade sleep quality because a significant portion remains active during the night. When caffeine clears, accumulated adenosine reasserts itself, causing a rapid return of heavy sleepiness and poor concentration. 2 simple checks can flag sleep deficiency: easy sleep again mid-morning and dependence on caffeine to function before noon. Chronic short sleep keeps adenosine elevated, producing persistent fatigue that harms health and performance. If you want practical ways to manage caffeine and sleep pressure, subscribe for weekly guidance built from evidence. People vary in their circadian timing, with morning types peaking early and evening types peaking later in the day. About 40% are morning types, 30% are evening types, and the rest fall in between. Chronotype is significantly influenced by genetics, so early or late preference is not a simple choice. Evening types may struggle with early start times because key thinking regions remain less active in the morning. Work schedules often favour early starters, which can reduce performance potential for later chronotypes during later afternoon and evening. Forced early wake times can lead to chronic sleep loss for evening types, increasing the risk of depression, diabetes, and heart disease. These health differences suggest that sleep timing is a biological variation similar to other physical traits. Flexible start times and later school schedules can better match chronotype diversity while still supporting shared goals. When society accommodates timing, individuals can protect sleep length and reduce the need for stimulants. Recognizing chronotype helps explain why identical bedtime advice works for some people and fails for others. Sleep can be identified by characteristic posture, reduced muscle tone, minimal responsiveness, and easy reversibility. Objective measurement uses brain waves, eye movements, and muscle signals gathered in polysomnography recordings. Research has revealed two major sleep types: non-rapid eye movement, NREM, sleep, and rapid eye movement, or REM sleep. REM sleep often includes dreaming and shows brain activity that resembles wakefulness in several ways. NREM sleep includes deeper stages where waking becomes harder, especially in stages 3 and 4. Across a night, the brain cycles between these states about every 90 minutes in repeating sequences. The balance is uneven, with deep NREM sleep dominating earlier cycles and REM sleep increasing later. This architecture means cutting sleep short often removes late-night REM sleep and some emotional processing. Protecting a full night supports both deep, restorative stages and later, dreaming-rich stages that serve different needs. Regular schedules and sufficient time in bed allow this natural cycling pattern to unfold with fewer disruptions. Rapid travel across time zones can misalign the internal clock with the local day and night timing. This mismatch can cause daytime sleepiness and nighttime insomnia because the brain still follows the previous schedule. The circadian clock adjusts slowly, often shifting by about 1 hour each day with sunlight exposure. Eastward travel often feels harder because it demands earlier sleep timing and compresses the day relative to the internal period. Melatonin signals darkness and can help shift timing in jet lag contexts by mimicking the normal evening rise. Melatonin affects timing more than sleep generation, so it sets the start signal rather than creating sleep itself. Frequent long-haul disruption in crew members has been linked with memory problems and higher rates of cancer and diabetes. These findings support treating circadian alignment as a health priority, especially for shift work and frequent travel. Better sleep requires consistent light, careful caffeine timing, and enough opportunity for full cycles of non-rapid and rapid sleep. To keep learning sleep timing tools and jet lag strategies, subscribe for clear science-based steps you can apply.